Hello, class, and welcome to the episode where hopefully I can make you just a little bit less fraction phobic. So let's start out with a fairly simple question. What are fractions? What does it actually mean? Okay? If you watched the last video that I put out there, the one about the weird number, you know that a fraction is some number, some natural or integer number, divided by some other natural number. A fraction is essentially a tiny division problem. Okay, so if I take the fraction 10 over 2, for example, that is the same thing as saying 10 divided by 2. And in fact, if you look at the symbol for divided by that we sometimes use, if you look at it and kind of squint, it looks sort of like a little fraction. This should all make sense. Now, when we have a fraction like 4/5, for example, there is a very big temptation to immediately throw that into the calculator and get the decimal 0.8, which is correct. These two are both the same number. However, it is often advantageous to stay in fraction form, because the nice thing about fraction form is even though there are two natural numbers there, you're still only dealing with whole numbers, right? There's a whole number on the top, and there's a whole number on the bottom. Whereas with 0.8, you're automatically dealing with numbers that are better suited for calculators than for our own understanding. For some reason, some students seem to think that the answer isn't the answer until they get a decimal like this. But fractions are numbers too, and they are perfectly valid, and they are valid to use as answers unless the instructions of your assignment specifically say that the answer has to be in a decimal. The last thing that we learned in our video was that any rational number, we learned the definition of rational number, but any rational number has many different forms it can take, right? So for example, if I had the number 1/2, well, that's the same thing as, say, 10 over 20. Right? And to get that, I would take this 1/2 and I would multiply the top by 10, and I would multiply the bottom by 10. And since I am multiplying the top and the bottom by the same number, what I'm really multiplying by is 1. And you can think of this like with the cakes, right? If I take a half a cake, well, that half a cake here is still going to be half a cake. Even if I split the whole cake up, that half of the cake is still half of the cake, even though it's clearly also now 3/6, right? There's 1, 2, 3, 4, 5, 6 equal-sized, roughly, I know I'm a terrible artist, pieces of cake, and 3 of them are shaded, so 3 over 6, 10 over 20, 1 over 2, they're all the same number. So now that we've got a general idea of what fractions are, again, just think of it as a miniature division problem that you don't necessarily need to solve. Now we're going to talk about what happens when you have multiple fractions and you are going to multiply them together. And this is really important because the relationship between multiplication and division is very, very similar to the relationship between addition and subtraction that we talked about several videos ago. So I'm going to go ahead and section this off, and we'll go down a little bit further. Okay, so let's put a couple of random fractions down. Let's say 4/5 times 2/3 times, I don't know, 1/2 times, let's just say 4. So we've got 4 fractions all multiplied together, but there are a couple of interesting properties here that we need to be aware of. First off, as I've mentioned before, but I just want to mention it again, this 4 over here is a rational number. It can be expressed as a fraction, right? We're going to call it 4/1. Now, later on, we're going to use big fancy words like reciprocal and stuff, but for right now, I just want you to think about it like this, okay? Everything here across the top, that's all multiplying, okay? All the stuff on the tops of the fractions, those are all numbers that you are multiplying by, okay? So you're going to have 4 times 2 times 1 times 4, okay? Now, these numbers on the bottom, these are all essentially numbers that you are dividing by, okay? We're dividing by 5, we're dividing by 3, we're dividing by 2, and I think that makes sense because, as we said before, a fraction is just a small division problem. So essentially what we're going to do is we're going to take all of the numbers that we are multiplying by up top, and we're going to multiply them all together. 4 times 2 is 8, times 1 is still 8, times 4, let's see, 8 times 4 is, 8 times 2 is 16, times 2 again is 32. Okay, so I get 32 on the top. And now I also want to multiply together all of the things on the bottom. Now, I know you might be thinking, hey, wait a second, Mr. Cunningham, you just said that the stuff on the bottom is dividing. And you're right, it is, and it will be at the end. But just like addition and subtraction aren't really different, multiplication and division aren't really different processes. If I take a number like 32 and I divide it by 5, and then I divide it by 3, and then I divide it by 2, and then I divide it by 1, that's the same thing as multiplying all 4 of those together first and then doing the division. Just like addition and subtraction, this process is commutative, which means it can be done in whatever order we want. So I choose to multiply all of the top bits and multiply all of the bottom bits, and then we can deal with the fallout afterwards. So on the bottom, we get 5 times 3 is 15, times 2 is 30. We get 32 over 30. Now, this is a valid answer, but a lot of teachers are going to ask you to put your fractions in what's called simplest form. Essentially, you don't want the top and the bottom numbers to both be divisible by the same thing. You want to divide out as much as you can in order to get the smallest fraction possible. So what we're going to do is we are going to notice that both 32 and 30 are divisible by 2, right? They're both even. Now, watch carefully. 32 is the same thing as 2 times 16, right? And 30 is the same thing as 2 times 15. I hope I haven't confused anybody yet. This is the exact same thing, right? We still have the same 30 on the bottom, and we still have the same 32 on the top, but you'll notice that we've got this 2 divided by 2. And again, since multiplication can be done in whatever order we want, we can take care of this 2 divided by 2 right away. And what is 2 divided by 2? Well, we learned from the last video that anything divided by itself is 1. Okay? So that 2 over 2, you hear the word cancel or eliminate being thrown out a lot, but it's not. It's not canceling, it's not eliminating, it's just equal to 1. That 2 divided by 2 right there is equal to 1, and we're just noticing that so that we can, and this is going to get kind of crowded for a second, get our final answer of 16 over 15. So just a really, really quick review. Anytime you are multiplying fractions, just remember to multiply straight across the top and straight across the bottom. And also don't forget that any natural numbers or integers that you're dealing with are also fractions, right? You can put any number over 1 and turn it into a fraction. So that's multiplying fractions, but what about dividing? I keep talking about dividing like it's the same and yet different from multiplication, and I haven't really done a good job of explaining that yet, so let's do that right now. Now, the rule looks something like this. When dividing fractions, we flip the divisor over, and I'll show you what that means in a moment, and we multiply, okay? I also want you to take note of this word reciprocal, because we're going to be using that a lot. Reciprocal is kind of like negative in that it's the opposite from a multiplication standpoint, okay? So for example, if I take 1/2 divided by 4/3, okay? 1/2 divided by 4/3. Again, division isn't really a thing on its own. All right, I know it looks like we're dividing by 4/3, but what we're really doing is we're taking 1/2 and we're multiplying it by 3/4. Okay, these are the same process, but one of them we know how to do very easily, right? Just multiply straight across the top, straight across the bottom, and we get 3/8. When you're dividing something, you're really just multiplying by the reciprocal. Just like when you are subtracting numbers, you are really adding the opposite, right? If I say 4 minus 3, that's the same thing as 4 plus -3. These are the same idea, okay? And the relationships are already there. We've already talked about them, and you already know some of the implications. What if I say something like 1/10 divided by 3? Okay? 1/10 divided by 3. Well, this doesn't seem like I'm multiplying or dividing fractions. It seems like one of them is just a regular whole number. And that's true, but again, as always, we have to remember that natural numbers like 3 are also rational numbers. It's 3/1. Okay, so if we are dividing by 3/1, well, that's the same thing as 1/10 times. Well, let's see. What's the reciprocal of 3/1? I use this kind of hand signal with my students to get them to flip the fraction over, right? So it's times 1/3, and that equals 1/30, right? 1 times 1 is 1. 10 times 3 is 30. 1/30 is my answer. And 1/30 is actually a really, really great example of why sometimes fractions are better. Because if you put 1/30 into your calculator to try to get an answer, you're going to get something like 0.03333333, and it'll never stop printing threes. Which is super inconvenient to write. Yeah, sure, we've got this bar that can go across the top that can denote that it goes forever, but it just looks super messy, whereas this nice, convenient 1/30 is much more aesthetically pleasing, it's much more neat and clean, and it's a lot easier to understand in my personal opinion. Anyway, let's get rid of this nonsense. So, wait a second, does that mean that regular ordinary division, just like we've always known, like for example, I know that 6 divided by 3 equals 2. Am I really saying that this is somehow a fraction problem? And the answer is yes. This is actually 6/1 times 1/3. And yes, we get 6/3, which is 2. So this new way of looking at division as multiplication by the reciprocal still fits in with all of the old rules that we knew about division when we learned about it in elementary school, and it was about taking groups and distributing them into even subgroups, right? We would take 6 divided by 3, and we would say, okay, well, if I had 6 objects, and I divided them into 3 piles, there would be 2 in each pile. This new system of reciprocals and multiplication fits perfectly with the rules that we've already established, which is important when looking at a new math topic. Okay, let's see. We've talked about multiplying and dividing fractions. We talked about how division is just multiplication again. So now we talk a little bit about common denominators, and hopefully I will make this understandable for you. Okay, so we're going to scooch over to the right here, and I am going to pick up an example problem from Khan Academy. So here's a problem that comes directly from Khan Academy off of the topic visually add and subtract fractions. All right, we've got 1/6, which is this rectangle right here. As you can see, it is divided into 6 equal pieces, and one of them is shaded, right? And then this second cake here, this second rectangle, has been cut into 3 pieces, and 2 of them have been shaded, thus 2/3. All right? So I want you to think of this like the cakes in the video that we watched last time. Think of this as a cake that has been cut into 6 pieces and a cake that has been cut into 3 pieces. Okay? If I was to add all of these up, well, I can't quite exactly see what's going on right now. That third and that sixth are different. I need to find a way to make them the same. Now, luckily, in this particular problem, it's pretty simple. If I have a cake that is cut into 3 pieces and another cake that is cut into 6 pieces, well, I can just take my 3-piece cake and divide each piece in half again, and now I've got a bunch of sixths. 4 of them, in fact. I hope that makes sense. I just took the 2/3 that I have and noticed that each third is the same size as 2 of these 1/6 chunks. I'm apparently not very good at saying the word sixth, so hopefully we're going to move on from this problem fairly soon. Well, now I can just count up what I've got here, right? I see 1/6 up top, and I see 1, 2, 3, 4, 6 on the bottom. And if I'm adding them up, well, that's going to be 5/6. All right, let's try another one of these and see if we're getting this down. So I have here this 1/2 plus 1/7. Now, this is a really weird one because unlike the last problem, in the last problem, we had pieces that fit together nice and neat, right? 2 of these 1/6 blocks was exactly equal to the 1/3 block that I had here. But now I've got 1/2 and 1/7, and they're really not anything alike. But there is hope as always, okay? Scooch this over a little bit. So anytime I have 2 bottoms that are just completely different like this, it's actually a fairly easy process, okay? Again, imagine that we have 1 cake that is cut into 2 pieces, and we have 1 cake that is cut into 7 pieces. How do I make it so that both cakes have the same size of piece so that I can do the addition and subtraction in a meaningful way? Now, here's the trick, and here's the trick we're going to talk about in the next video as well. If I know that there are 2 pieces in one cake and 7 pieces in the other cake, essentially all I have to do is take each of the 1/7 and split it into 2 pieces. 2 pieces each. 2 pieces, 2 pieces, 2 pieces, 2 pieces. Okay? Essentially, because this cake up here is cut in half, I'm taking each of the pieces of the bottom cake and cutting each of those pieces in half. Similarly, I am taking each piece of the upper cake and dividing it into 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, how many pieces do I have total for each cake? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces and 14 pieces. Now both cakes have the same size pieces, so we can talk about them. Well, how many pieces are there in that upper cake now that I've cut it into 14? Well, 1, 2, 3, 4, 5, 6, 7. So what I've really got here, instead of 1/2, is 7 over 14. Again, they're the same thing. 7 over 14 is just one of 1/2's many forms. And how about this cake on the bottom? Well, there are still 14 equal pieces, and only 2 of them are shaded, so that's 2 over 14. And then all we have to do is take all of our pieces and put them into one group and count them again. I have 7/14 in the top cake. I have 2/14 in the bottom cake. If I add up all of those 14ths, I have 9/14. And that is why you need to find the common denominator. In the next video, I'm going to do a bunch of examples of adding, subtracting, multiplying, and dividing fractions. And I will show you the fastest and simplest method to get a common denominator every single time without having to do half the work that you probably had to do when you first learned this. Until then, I hope you're staying safe. I hope these fractions are a little bit less intimidating to you than they used to be. And as always, please do make sure to leave your questions in the comments. I will do my best to answer as many of them as possible. I do have another channel, by the way. I have a channel called The Mathematics of Vice. I would love for you to subscribe to that one as well. Either way, I hope to see you next time. Thanks for watching.